Today we are going to start module 3, and in module 3 basically uh, module 3 is based on extrusion type of additive manufacturing processes. Okay, so yeah, yes. So in extrusion based additive manufacturing processes, first we will try to see the what are these extrusion based additive manufacturing processes. Then we will see the methodology, the process, the materials, and the methods which are developed among the additive extrusion based additive manufacturing process. Okay, so yeah, uh, yes. So as the name indicate, extrusion based additive manufacturing process, the material is extruded through some nozzle. Okay, so here you can see numbering 1, 2, and 3. Okay, so first is corresponding to your nozzle. You can say you are having a nozzle, and then you are having the material which has been deposited, and then or the part that has been fabricated using your extrusion-based additive manufacturing. And third, we are having your build platform, and yes, obviously this the motion or the movement are provided to your nozzle. Okay, so in the case of extrusion, in the earlier cases when we were discussing powder-based additive manufacturing processes or the laser-based additive manufacturing process, or what we could see, we were controlling the path of our laser. Okay, whether it is UV laser or any other kind, but we were controlling the tool instead of controlling moving the nozzle, we were moving the UV laser, and your material was kept above your build platform, whether it is in the form of yes, in the case of SLA, it was in the form of liquid resin. But here your material is coming through a nozzle. Okay, so here your material is kept somewhere in the form of a spool. We will talk about these spool, how this material is kept in these spool, and then it is extruded through this nozzle. Okay, so since it is supposed to be extruded through this nozzle, some arrangement needs to be done, like for proper melting is needed, and some extrusion mechanism is needed for controlling the flow of material. Okay, and in the case of these extrusion-based additive manufacturing processes, how this material is getting deposited, it is coming out through the nozzle, and it is getting deposited on your build platform. Suppose we are building our first layer. Okay, then it is being either deposited on your build platform or on your support material. Okay, sometimes few layers are created of your support material if you are having more than one nozzle. Okay, if you are having single nozzle, then few layers are created, porous layers are created with having less density. It means they are not that much closer with each other like your actual build part. Okay, so this way, suppose your first layer is created by extruding your material above this build platform, and this extruded material is called as the road of your extruded material. Okay, so it looks exactly like it, but since the diameter of your extruded this you can say material is very small, uh, it it it, it takes the final shape as per your slice data. Okay, yeah. Let us talk more about extrusion based additive manufacturing processes. These technologies can be visualized as similar to cake icing. You might be knowing cake icing process. in that material contained in a reservoir is forced out through a nozzle when pressure is applied. If the pressure remains constant, then the resulting extruded material, commonly referred as rods, will flow at the constant rate. Okay, so normally it flows at the constant rate and will remain a constant in cross-sectional diameter. Okay, so what we could see here, these rods of your extruded material, these are having uniform cross-section as well as these are being extruded at uniform constant velocity. Okay, that is constant velocity from the nozzle. The diameter will remain constant if the travel of the nozzle across a depositing surface is kept at constant speed that correspond to your flow rate. Okay, so we have to make a balance between your between the nozzle speed as well as the material flow rate. Okay, so if these two speeds are equal, then the diameter uh, of your rod will remain the constant because it the material is getting deposited on the platform with the same rate same rate at which it is coming out of your nozzle. Okay, so this is how the constant diameter is maintained. Constant diameter of the rods is maintained in the case of additive manufacturing processes. The material that is being extruded must be in some semi-solid state when it is coming out of the nozzle. Yeah, it is a mandatory thing because we cannot obviously deposit the solid wire or bar on your build platform. We have to heat it. This heating arrangement may be inside your nozzle or before coming into the nozzle, the material must be in a semi-solid state. Normally, it is some heating arrangement is provided when this material is is going inside your uh, your uh, your uh, your nozzle. Okay, so heating arrangement is itself kept inside your nozzle. Okay, so this is how the material which comes out of the nozzle, it is in the semi-solid state, so that it can easily adhere with the other or the previously printed material of your additive manufacturing process. Yeah, the material must fully solidify while remaining in that shape. Okay, so the shape of the material should not change during the solidification. The material must bond to material that has already been extruded, so that a solid structure can result. Okay, so yeah, so the material that has been you know extruded, it must there is must make a bond with the previously extruded material on the your previous layer or the build platform. Yeah. So talking about the basic principles, yes, the main things in order to understand the extrusion-based additive manufacturing processes are or you can say basic steps in extrusion-based additive manufacturing processes are loading of material, then liquefaction of the material, application of pressure to move the material through the nozzle, then extrusion, plotting according to predefined path and in a controlled manner. Obviously, it is done through the in a sliced manner. Okay. Then bonding of the material to itself or the secondary build material to form a coherent solid structure. That is mandatory. That it should there or it should make a bond with the same material or the secondary build material that has been supplied. Okay, the inclusion of support structure to enable complex geometrical features. Yes, a support structure as mentioned in the other additive manufacturing processes is mandatory. to print complex geometrical features. Yeah. Moving ahead. Yeah. So as I told that we will be discussing about these seven basic steps in extrusion based additive manufacturing process, and the first step is the loading of material. Okay. So as I told that the material is in the form of solid form, and it is it comes in the spool of your material that has to be printed. Okay, so since the material is uh, since extrusion is used, there must be a chamber from which the material is extruded. This could be preloaded with material that, but it would be more useful if there was a continuous supply of material into this chamber. Okay, so if the material is in a liquid form, then the ideal approach is to pump this material. Most bulk material is, however, supplied as a solid, and most suitable supply are in pellet or powder form, where the material is fed in a continuous filament. Okay, so the chamber itself is therefore the main location for liquefaction process. Yes, liquefaction takes place in the chamber. Pellet, granules, or powders are fed through the chamber under gravity or with the aid of screw. Material that are fed through the system under gravity require a plunger or compressed gas to force it through the narrow puddle. Okay, so here you can see the spools of material. You can these comes in different color and shape. Okay, the diameter of your spool vary depending upon our requirement. Okay, so here you can see multiple colors: red, white, blue, green, yellow, black. Okay, so the material itself comes in these form. Okay, if you go in market, you can purchase these uh, spools from the market easily. Okay, uh, and after loading, this material goes into your nozzle. Okay, that part we will discuss. Okay, screw feeding not only possess the material. Okay, this is the advantage of screw feeding, because the material has to be come out at a constant speed from the nozzle. Okay, so the screw feeding not only pushes the material through the base of the reservoir, but can be sufficient to generate the pressure needed to push it through the nozzle as well. A continuous filament can be pushed into the reservoir chamber, thus providing a mechanism for generating a input pressure for the nozzle. Okay. Then coming to the second step, that is the liquefaction. The extrusion method works on the principle that what is held in the chamber will become a liquid. Okay, so since your material which is coming inside this nozzle, it is in a solid form, but as soon as it goes inside this liquefaction chamber, because it is your nozzle, and which is having a liquefaction chamber or liquefier chamber. Okay, so in this liquefier chamber, some heating arrangement is done. The material could be in the form of solution that will quickly solidify following the extrusion, but the more likely this material will be liquid because of heat applied to the chamber. Okay, so since heat is applied to this chamber, your solid material is converted into semi-solid form, or you can say some liquid form. Okay, so and it comes out of your this nozzle tip. This is your nozzle tip. Depending upon the diameter of your nozzle tip, it comes out of your nozzle. Okay. The heat would normally be applied by the heating coil wrapped around the chamber. So here you can see some heating coils which are wrapped around this chamber. These are indicative of your some wrapping of heating coils, uh, which are responsible basically melting of your filament material, or the material which needs to be extruded. Yeah. Let's moving ahead. The extrusion nozzle determines the shape and size of your extruded filament. Yeah, it is quite sure. A larger nozzle diameter will enable material to flow more rapidly, but would result in a part with lower precision compared with original CAD drawing. Okay, so yeah, it is obvious if you can use you know uh, 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 nozzle or nozzles which are having larger diameter. Okay, larger you know the larger diameter. Okay, but the issue is that the surface quality or the quality of your printed product will not be that much which you were expecting or which you desire. So, in order to improve the quality or the deviation from the original desired product, you must make a compromise between the laser your nozzle diameter and your build quality. Okay, that compromise you have to do depending upon your part requirement or the application. The diameter of the nozzle also determines the minimum feature size that can be uh, created using your additive manufacturing process. No feature can be smaller than this diameter. Yes, obviously it is clear that you cannot create any feature smaller than your nozzle diameter. Yeah. Okay. And these are quite practically in practice the feature should be normally be large relative to your nozzle diameter to faithfully reproduce them with satisfactory strength. The extrusion processes are more suitable for larger parts that have features and wall thicknesses that are at least twice the nominal diameter of your extrusion nozzle use. Okay, so minimum twice of uh, your minimum feature size should not be or the wall thickness should be at least twice the nominal diameter of your extrusion nozzle. The material will flow through the nozzle is control material flow through the nozzle is controlled by the pressure drop between the chamber and the surrounding atmosphere. Yeah. Then next step is the solidification. Once this material is extruded and deposited on your build platform or your previously printed layer, it must solidify. Okay. So what are the requirement during the solidification? Once the material is extruded, it should ideally remain the same shape in size. The size and shape and size of your your extruded material should not change once it is getting solidified. Gravity and surface tension, however, may cause the material to change shape. Yeah, since it is in the form of liquid, obviously due to the gravity, the uh, uh, material get distorted as well as due to the surface tension. There may be minor changes in your shape. The size may vary according to cooling and drying effect too. Okay, so suppose you are having, if you are using rapid cooling, then these effects may be very high. If the material is extruded in the form of gel, the material may shrink upon drying as well as possibly becoming porous. If the material is extruded in a molten state, it may also shrink when cooling. The cooling is also very likely to be non-linear. If the non-linear effect is significant, then it is possible that the resulting part will distort upon cooling. This can be minimized by ensuring the temperature differential between the chamber and the surrounding atmosphere is kept to a minimum. That is, use of controlled environmental chamber when building the part, and also by ensuring the cooling process is controlled with a gradual and slow profile. Okay, yeah. I will move in the fast forward mode because some of the things which are already discussed in other processes, more or less the things are same. So positional controls, like many other additive manufacturing processes, extrusion-based additive manufacturing process use a platform that indexes in the vertical direction to allow formation of individual layer. The extrusion head is typically carried on a floating system and allow movement in the horizontal plane. This floating must be coordinated with the extrusion rate to ensure your smooth and consistent deposition of your material. The floating head represents a mass and therefore contains an inertial element when moving in a specific direction. Okay, so since there may be any change in direction must result in a deceleration followed by acceleration. Okay, so since there is acceleration and deceleration in the movement of your nozzle or the or your floating head, you must maintain the same acceleration and deceleration in the material flow rate. Okay, so the otherwise there will be a mismatch in the material quality. Okay, the corresponding material flow rate must match with the change in speed, or else too much or too little it will be deposited in a particular region. Suppose it is too less, then there will be shortage of material and your part may get distorted. Or if it is too high, then the extra material may get printed at these areas, and again your part will be distorted. Rapid change in direction can make it difficult to control material flow rate. Okay, so if you are moving your plotter head with a very high speed, or at a very high speed, if you are trying to change the direction of your plotter, it will be quite difficult to maintain the flow of your material during these rapid directional changes. Okay, so a common strategy would be to draw the outline of the part to be built using a slower floating speed to ensure that material flow is maintained at constant rate. Okay, so initially we can try at low speed, and then we can go for higher speed. Yeah. Next part is your internal fill pattern of your during the printing of your any layer, any particular layer. So the internal fill pattern can be built more rapidly, since the outline representation of the feature of the part that correspond to geometric precision. Okay, so here you can see when you are trying to print your these outer uh, external features. Okay, like this is your external feature. Okay, so for printing this, we need to be very we need to print at a very precise speed. But for printing internal fill pattern, okay, suppose you are filling here, so you can move rapidly. Okay, you need not to worry about the you know feature feature surface quality, because obviously it is being it will be another layer will come on, another layer of extrusion material will come on this particular layer. Okay, so we have to take care about the external features only. We need not to worry about the internal feature. It can be not internal feature, actually internal layer. Okay, this outer cell also represent a concentric region that will prevent the filler material from affecting the overall precision. Yeah. Then next is your bonding between your between the material. Okay. For heat-based system, there must be some sufficient residual heat energy to activate the surface of your adjacent region, and which causes bonding in the material. The gel-based system must contain residual solvent or wetting agent in the extruded filament to ensure the new material will bond to the adjacent region that have already been deposited. In both the cases, we visualize the process in terms of energy supplied to the material by the extrusion head. If there is insufficient energy, the region may there, but there would be a distinct boundary between new and previously deposited material. Okay, this can represent a fracture surface where the material can be easily separated. Yeah, too much energy may cause the previously deposited material to flow, which in turn may result in the poor defined surface quality. Okay, poor defined part. Okay, so we have to make a balance in terms of energy supply to your extrusion head, because we could see if we are applying the insufficient energy, your layer will not adhere with each other in a proper manner. If the energy supplied is too high, then there may be, you know, overheating in the previously layer, or your material previously deposited material may also get melted, and ultimately it will reflect in the overall quality of your part, which needs to be printed. Okay, so for today we will stop here, and we will discuss the rest part in the next